Hi and welcome. I am trying to learn particle physics. Today, matter, antimatter, imbalance. And after we've done it, we're gonna do, I'm right now thinking if we should do neck stretching or yoga. Yoga. We're gonna do yoga. And if you participate in the yoga, then it's with the armrest. The standard model of particle physics is underpinned by the quantum field theories that Paul Dirac and many others developed. I don't understand the word underpin. I think I mean that what Paul Dirac and a lot of other people said about the quantum fields is important for particle physics and its standard model. So what all the atoms, which are all the physics about these particles is about. It depicts empty space as a joiling quantum vacuum of particles and antiparticles that pop up as pairs and confidently predicts that the Big Bang created equal quantities of matter and antimatter. Let's read both sentences again. The standard model of particle physics is underpinned by the quantum field theories that Paul Dirac and many others developed. It depicts, the standard model. The standard model depicts empty space as a joiling quantum vacuum of particles and antiparticles that pop up as pairs and confidently predicts that the Big Bang created equal quantities of matter and antimatter. Okay, the standard model says that the Big Bang has created so and so much particles and antiparticles and all which ones who are listed in the standard model of particle physics. They would have indulged in cyclical orgies of annihilation and recreation until the cooling, expanding universe could no longer supply enough energy for this. Okay, all these particles and the antiparticles were created and eliminated, annihilated, if it wouldn't be so that it is not so. And it would have only ended if it would have been so, as the universe had cooled down. At that point, not a lot would have happened. The last matter-antimatter pairs would have annihilated, leaving the cosmos suffused with nothing but a lot of light and energy. They would have indulged in cyclical orgies of annihilation and recreation until the cooling, expanding universe could no longer supply enough energy for this. The cooled universe is not supplying enough energy for the cycle of annihilation and recreation. And at that point, things had stopped to happen, a part of energy and light existing. The material universe of stars and galaxies and planets would have failed to materialize, so there wouldn't be any Earths or planets, or galaxies or stars. The fact that we are a world completely dominated by matter is completely ununderstood. Okay? Says Chloe Mabronot at Particle Physics Lab CERN near Genua, Switzerland. Theory says we shouldn't be here. They are saying that if it would go all after the joules, then at the time that the universe had cooled down, and there wouldn't have been enough warmth for the creation and annihilation of all these particles and the antiparticles. That means, according to the rules, we're not existing. But de facto, that we exist to raise an eyebrow at this prediction is the only rebuke it needs. I'm not able to understand the sentence, but I understand what I mean. I mean that we're able to raise an eyebrow about the question that we're not existing is enough proof that we are existing. We are being made of matter, living in a material world, while antimatter is reduced to an eternal bit part player. I don't know what a bit part player is. What you mean is, in the world in which the humans are seeing the world is the one in which they themselves and all the things around them exist out of matter and material. And the antimatter is obsolete. One conversation solution is that the antimatter isn't gone. The antimatter isn't gone. One conservative solution. Okay, the antimatter isn't gone. It's just hiding with far-flung regions of the universe made entirely of antimatter. Okay, one theory is antimatter is there, but it's just not here. It's somewhere else in some big cave. It's hiding. The trouble is, you would be able to see the joints. Long, thin seams of gamma ray light produced by the annihilation of matter and antimatter wherever two opposing regions meet. At that place where that big oil field of antimatter is, at its borders, there would be some beam of gamma visible where it touches the matter regions, because at that place there would be reaction happening. Maybe a bit like in the last Harry Potter movie, the Daumus Blade of Hogwarts Castle. We've never seen any signal like that from anywhere, says Marco Gerselbeck at the University of Manchester, UK, and CERN's Large Hadron Collider Beauty Experiment. We've never seen any signal like that from anywhere. So we haven't seen anywhere a reaction happening at the place where the antimatter field meets the matter field. A phenomenon called CP symmetry gives a hint of a plausible alternative. Okay, where's another idea why it is so that there is matter and antimatter, whatever. The idea is that since matter and antimatter are just mirror versions of one another, for each type of particle there is an antiparticle with an opposite charge. This is C symmetry and parity or P. Put together, these make CP symmetry. For each type of particle, there is an antiparticle with an opposite charge. This is C symmetry and parity or P symmetry. But together, these make CP symmetry. No, that's it. But for some matter to have survived the early universe, there must be some other differences between matter and antimatter. Why is it not probable that matter exists? In other words, CP symmetry would need to be broken. For that matter exists, CP symmetry had to be broken. The breaking of parity symmetry alone had already been established by Qian Wu in the 50s. In 1964, investigations of particles known as kaons and the antiparticles showed that perfect CP symmetry and the naive picture of matter and antimatter as perfect mirrors didn't hold. Okay. They said CP violation, that Qian Wu proved the CP violation. So what we're explaining here with the C symmetry and the parity P symmetry, CP symmetry, is what is not existing. It is not existing the CP symmetry that there is for every matter and antimatter or whatever. And in fact, the naive picture of matter and antimatter as perfect mirrors didn't hold. That raised many more questions. What makes antimatter different? Yes, the question is, why is there less antimatter than matter, if they're all coming with a body? Are some types of antimatter more different than others? And why should... I'm stumbling over this. Some types of antimatter are different than other types of antimatter. It makes a lot of sense. But we said here in the last part that matters have different types of charges, antimatter charges. There could be someone with minus 1/3 charges, one with plus 1/3 charge. So why would really all be the same? And why should this be, that they are more different than others? Because they're mirroring the other one, and they are different. Now, why is matter different from other matter? Because they said that the sun is creating other things, because there's a slight difference in the proton and neutron mass. Are there other types of antimatter corresponding to new types of matter we haven't discovered yet? I can't follow. Are there other types of antimatter? Okay, there are different types of antimatter. Maybe they are corresponding to new states of matter we haven't discovered yet. And there are more types of matter we don't know about it, and they are the mirroring one to the we have found the interparticles to the particles we haven't found, to the metaparticles we haven't found yet. That's what we say, or one theory, one suggestion. And that is said by Tara Shears at the University of Liverpool, United Kingdom, and the Large Hadron Collider Beauty Project. Answering those questions is the key to working out why we are here now. We want to know why they exist. Theorists later found that CP violation among kaons could be explained if three heavier, unknown particles were disrupting them. All three of these particles have since been found, bottom, charm, and top quarks, and their presence along with CP violation is now a mainstay of the Standard Model. Theorists later found that CP violation among kaons could be explained if three heavier, unknown particles were disrupting them. All three of these particles have since been found, the bottom, charm, and top quarks, and their presence along with CP violation is now a mainstay of the Standard Model. Those particles also provide new source of CP violation. In the intervening half-century, intervening? How can a century be intervening? In the intervening half-century, we have measured all the main predicted sources with LHCb, measuring the last among charm quarks just last year. We have found the sources of quarks. Now the whole thing looks completely understood and all is well, says Yazabek. Well, all is well. There is just one tensy problem. Well, it's not all. Patterns in the cosmic microwave background, the leftover radiation from the Big Bang, combined with calculations of a number of galaxies that must exist, tell us the early matter-antimatter imbalance we need to explain today's matter domination. What? Patterns in the cosmic microwave background, the leftover radiation. Okay, but a pattern in the way which cosmic microwaves are happening in the universe, and also the amount of galaxies existing in the universe. Tell us the early matter-antimatter imbalance we need to explain today's matter. I can't make sense out of that sentence. Tell us the early matter-antimatter imbalance we need to explain today's matter domination. It is tiny, about 1 part in a billion, but the CP violation we have found so far doesn't account even for a billionth effect. Now, we don't have time, I forgot we switched to yoga, but that's far behind schedule. It was a particle physics part. If you were here for particle physics, you can go directly to the next part of particle physics. If you stay and participate in the fast and short, then yoga findet ihr anders. Wie findet ihr anders? Out and down, the sprouting flower, in and up. Out and down. And out and up. Out and down. In and up. Out to the side, the police officer, in and up. Out to the other side, in and up. Inch the space between your feet, out to the side, in and up. And out the hide and seek plane, palms feet down, again in and up. Out to the other side, in and up. And out and down. In and up. And out, lean onto the knees, breathe in. And out, make a head of the back, again. And out the belly of the back, in. Out the head, in. Out the belly, again in. And out come with the round back up, the top backward shoulder right at the top. Breathe in the arms up. And out come up onto sit downs. Breathe out and sink down into the chair. This can go under the knees. In and up again. Out and down. In and up. And out, bring the arms of the sides down, feet together. Side to underload, just keep hanging down. Now make the legs wide and forward, and we keep on hanging down the Niagara Falls. Breathe in. And out comes slowly back up and make it the top of backward shoulder. The feet are standing together, breathe in the arms. Out close the arms to 20 fingers, breathe in, reach high. Out, reach in front, hold the back. In and up. Change over crossing, breathe in, reach high. Out, reach in front, hold the back. In and up. Out, lean back, drop a shoulder blades together. In and up. Out again, back, drop a shoulder blades together. In and up. Out the arms down. The eagle swings, lift the arms up. Out and down. Again, in the arms up. Out and down. And the cactus collecting its stings in the evening. Breathe in, lift the arms up. Bring the hands to touch and now the hands down to heart center. And it was a fast and short. Thank you very much and until next time.